Next, we're going to look at absolute value. So if I have some number, and we'll call it a, we want to know exactly what its absolute value is. And it's denoted by these vertical bars. This is how we denote absolute value. The actual definition is the distance from this number to 0 on the real number line. We want to know how far away we are from 0. Distance is always positive, so our absolute value is going to be greater than or equal to 0, no matter what a is. So the way we actually define this is a, if a is greater than or equal to 0, minus a if a is less than 0. So let me explain exactly what this means. If our number that we're taking the absolute value of is positive in the first place, then we're going to just leave it exactly the way it is. However, if our number is negative, then I'm going to change the sign of it. So let's do a couple of examples. The absolute value of 7. Since 7 is positive, we just have 7. The absolute value of negative 7, we want to change the sign to make it positive 7. Absolute value of 0 is 0. The absolute value of pi minus 7, what is this? Well, we know that pi is approximately 3.14, so this number here would be negative. So it's negative pi minus 7, or we can rewrite that as 7 minus pi. There are several properties we can look at whenever we use absolute value. One that I've already stated is it's always greater than or equal to 0. It's always either positive or 0. Another, the absolute value of a is equal to the absolute value of its negative. The absolute value of 5 is the same thing as the absolute value of negative 5. The absolute value of a product is the same thing as the product of the absolute value. So whenever I'm taking a product, I can multiply it and take the absolute value, or I can take each of the absolute values first. And the same thing works for division. The absolute value of a over b is the absolute value of a over the absolute value of b. My very last property that I'm going to look at is known as the triangle inequality. And it's probably one of the trickiest ones. Absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b. While I can break an absolute value up over multiplication and division, I cannot exactly do that with addition. Instead, it gives me this inequality. If I try to take the absolute value of each number first, I could actually be making this thing grow. Very much related to absolute values is the distances between two numbers. So if I have two numbers, a and b, and I want to find their distance, we denote it by this d of ab. So this is distance. It's given by the absolute value of b minus a. And because of our properties of absolute value, that's the same thing as the absolute value of a minus b. So it doesn't matter which one of these two you use. So for instance, if I have the numbers 4 and 8, I can do the absolute value of 8 minus 4, or the absolute value of 4 minus 8. Here I would get the absolute value of 4, which is 4. On the right, the absolute value of negative 4, which is 4. What about this one? Negative 3 and 7. So I'm going to call the first one a and the second one b. So the absolute value of b minus a would be 7 minus negative 3, which is the same thing as 7 plus 3, which would give me 10. As one more, if I do negative 1 and negative 8, once again I'm going to call this a and b. I would have the absolute value of b minus a, which would be negative 8 minus negative 1, the absolute value of negative 7, which is 7.